acting also as a short spoiler for tomorrow's POC that we present in the ecosystem day. It's a work that we have been jointly doing with my colleague Nikos and Apostolos Prosas from Ubitech in the last weeks. In the context of Proteus mostly project, trying to see the mapping between IETF and TFS, using P4 as a case here, not as a, we try not to make it bound to P4, but rather see how the synergy of IETF and TFS more broadly could be exploited. P4 is just the case here. So I'm not going to spend time to explain the network slice as defined by IETF. I'll just go directly to the point here. We would like to see it as a means to provide transport connectivity in various use cases. This is the original definition of the RFC. There's a good analogy that I found very, very intuitive as I was trying to see the different key entities of this IETF network slice. They represent the whole slice as a train service. And some key points of the slice, like the SAPs, service aggregation points, SDPs, the connection groups, can be seen as, for example, stations or control points in the railway or groups of trains and stuff like that. So it's a good way to basically understand, the internals of the IETF slice and why they're useful. So seeing this as a train service, basically we see the whole slice as a train reserved for specific passengers with some defined requirements. The passengers for us is the traffic basically, and the traffic requirements that the one who needs the slice can hold. There are service attachment points in the slice, which we make an analogy with the train stations here. So it's the point where the passengers enter or exit the system. And for us, it's the entry or exit points of the customers, basically, those that want to use the slice. The SDPs, service demarcation points. These are the control points in the railway system. And for the network, it's the internal boundaries in the network, defining where the slice applies, where it needs to be enforced in the network. And finally, the connection groups. It's basically how we bundle the traffic together by means of similar needs, like traffic chunks, which have similar requirements like low latency video, critical IoT data, or other types of traffic. And then it's how we realize this in the underlying infrastructure. So here, basically, in every network pretty much today, a shared infrastructure could be used at the physical layer, but on the customer layer, this appears to be like a dedicated network for him or her, because we use virtualization a lot. So we kind of hide the underlying physical equipment, and we promote the slice as a unique network for the customer, although it's actually using shared infrastructure resources underneath. So how we try to approach this in our POC tomorrow, we have a specific case here.
If you have any questions.
So, the slice as seen from the operator versus the slice as seen from the client or the customer. Can you reflect on that in your storytelling? Because I map multiple, let's say, logical networks onto, let's say, a few instances of, let's say, operational slices in my context. But I have many enterprise customers mapping many logical networks onto fewer.
Well, the difference is that the customers cannot see the physical infrastructure. They just see what you provide them as a logical network or connectivity service. And they don't need to bother how it is actually realized in the data plane, right? So the operator can see everything, of course, how the logical slices are mapped to physical infrastructure, but
or still it's logical network, but logical at a more aggregated level. But your focus is, as I take it, more from the, let's say, the client or the customer perspective.
Well, in TFS it should be both actually, but yeah, we need to cut on both directions here.
Yeah. Okay.
So the case that we took to basically investigate this is using ORAN as an example here. So assuming that kind of a 5G operator wants to deploy a 5G system based on ORAN, they would typically try to use some radio access network components, ORUs, ODUs, for example, OCUs for the baseband processing as well, and then for the 5G core. So depending on the functional split that you choose here, the ODUs and OCUs can be placed in different locations, but it doesn't really matter. From the standpoint of the owner of this 5G system, all he wants is, depending on the split, being able to provision some transport connectivity services. In this specific case that we have in our POC, it's, for example, there is a need for a mid-haul transport network which connects the DU with the CU, and a backhaul one which connects the CU with the 5G core. If we had a different split, we would need probably a different transport service, but and between other components. For example, there could be front haul one between RU and DU. In that case, we would also use the wrapper. It doesn't really matter which split we choose. It's the need of the operator to have connectivity services as a service, kind of. So asking to connect different endpoints in the network, right? The way we approach this is we look this from the SMO viewpoint of the ORAN system. This SMO component here needs to establish the whole system, the whole working system. But this is typically a combination of compute resources and network resources. And we have orchestration components in both sides. So some SMO could use here, I don't know, maybe OpenSlice, for example, to allocate compute resources, like Kubernetes clusters, where we can deploy the ODU, the OCU, the 5G core, for instance. But then it will also need to consult a network orchestrator to deploy the connectivity services and then stitch everything together, right? So we investigate the possibility of using the IETF Network Slice model here as a means for the SMO to talk to the network orchestrator, and we use TFS as a network orchestrator in this case. And the slices that we try to allocate, as I said, it's in this specific case, it's a mid-haul between the UCU and the backhaul one between CU and the 5G core. And then we try to make it technology specific because we had to do a POC, right? Somehow we need to evaluate how this may work. So since we are developing a lot of services within Teraflow, especially in P4, we thought that that could be an example. It might not be the most relevant example in some cases, because, for example, to connect the antennas with the backhaul part, let's say, of the system, you may typically use optical equipment, right? In that case, you could have another Teraflow service here which uses optical, but it doesn't really matter because the APIs are similar. So you would call it in a similar way. It's just the driver that may change. So in our case, we used P4, and we thought that this is a good split for P4 because, especially for the mid-haul part, it typically sits in a kind of a data center environment. The DU and the CU both of them are software functions, and you can deploy them in a Kubernetes cluster, and you can use a P4 switch to interconnect them. That's a very good case for P4. For backhaul and fronthaul, you could have optical, of course, but here we also use P4 as a backhaul too. Technologies that we use specifically is from the ONF work. We use Stratum as an operating system for the switches on top of P4. And we use SD Fabric as a forwarding data plane. So they have done a lot of work in SD Fabric in ONF to implement P4 programs, which do a lot of useful network functions, especially even for 5G, even for UPF processing. So it's a rich library of P4 capabilities. And the good thing here is that it applies both in hardware, it's compatible with Tofino, and the same one also applies for software switches. So with the same kind of library here, you can have Tofino-based deployments and also even Minden deployments with the same kind of code. So it's useful. Yeah.
Did you use for the POC Tofino switches?
No,
Software.
it's software based for now, but it's a kind of a future work for us, immediate future work to replace the software BMB2 switches with Tofinos. Now, how we took the specific example, I try to simplify a little bit the figure and show that we use a P4 switch which needs to connect to domains. It could be either DU, CU, CU, 5G core, it doesn't matter. We take some part of the JSON of the IETF model, in this case it's the SDP list, and we saw a clear mapping with what we're doing before and TFS, right? So in this SDP, basically you declare the endpoints of your slice, of your connectivity service, so to call it. And in our case, it was pretty obvious. We wanted to connect the DU and the CU. We knew what is the endpoint of the DU, we knew what's the point of the CU, and we are able to fill this very well. So by means of declaring the SDPs, it's easy because we already have this in TFS. We already speak about endpoints, connections, and services on top. So it was easy. Speaking about connection groups, we are also able to fill in this information about the sender and the receiver. It's basically a mapping of those things to the SDPs on top. But the problem we encountered, and I think this needs to be discussed also in the context of the network / controller group now, is what we do about SLOs here. There was no way for us to impose the SLOs, and there are multiple reasons for that. And this is just a reflection that I would like to give today. Basically, we lack a few features in TFS to be able to do that properly. Because providing a slice by means of connectivity is okay, it can be done. We did it already for the POC, but providing a slice with guarantees is a different story, right? So this is what we would like to elaborate here. In the device layer of TFS, we need to be able to implement quality of service.
We have something, for example, in IP routers, we can have dedicated flows.
Mm-hmm. Yeah, there could be parts of TFS which do this already, some drivers. But for our case, for the P4, we never did it. The good thing, though, is that in this release, we put a lot of support for SD Fabric, and this is the first time we do this exercise in TFS. And SD Fabric already touches upon quality of service. They have dedicated tables and pipelines for quality of service. And as I said previously, it covers both Tofino and software switches. So the good thing is that SD Fabric is now integrated in TFS in release 5. It will appear now. And if we move this now into the service layer, we just need a couple of new service handlers, which will be able to manipulate those specific quality of service tables in the SD Fabric data plane. So if we're able to commit those service handlers in the near future, we will be able to do something around quality of service.
Sorry, just trying to understand. Here you mean by service handler orchestrator or
no, the service handler is basically a concept inside TFS.
I talk about service plugin.
Plan is like scheduling.
It's
Scheduler.
no, it's the let's say the instantiation of a specific service which takes care of a specific device.
Mm-hmm.
Typically, you have a device plugin which does all the connection for the configuration for the device, but you need a service handler for this, which is the one having the well, yes, and that goes from the view of the service up to the devices.
Yeah, correct. We have quite a lot of service handlers in TFS at the moment, but in the P4 domain, none of them does quality of service. This is one of our future work. The other thing is that, and this goes now broadly into TFS, for TFS to be able to provide those kind of slices with quality of service, we need to also reconsider how we call the various RPCs of the service component. We have set delete configuration, set delete constraint, but if you look in the different service handlers within Teraflow, not all of them implement those methods basically. So if we want to pursue the IETF path, I think we need the owners of these handlers need to start putting code there so as to implement those features. And the last thing that I have to mention here is about path computation.
We need to completely remove this.
Either we need to revise it from scratch, because at the moment it's really hard. I mean, the path computation works for specific cases. It's not that flexible, and without the proper path computation within TFS, we cannot do much. That was a quite big pain for our POCs tomorrow. And I think we need to heavily put some effort there to make a very good path computation component for TFS, or consider using some existing, like, I don't know, if there's an external service that we could use.
Open source, you will not know. But if we simplify it, it will get better easy. Let's say it's about removing all the C code stuff there, and this will gain a lot. And don't expect it to work to overload it. But new functionalities.
I'm a bit curious because I think in many cases in our networks, you don't use a very dynamic path computation. The path computation is sort of done once you establish the topology. And then it's more a matter of traffic steering when things are entering let's say, the topology, you do traffic steering in order to reach the other end of the segment.
But but for traffic steering to be able to see what to configure next, needs to know what are the possible paths, right? So it has to query path computation, get the possible paths.
But is it path computation or is it path selection?
Well, you can call it path selection as well.
Both. It first computes, and then there's part of the service which selects the computation.
The computation is done, let's say, once and for all when you establish the topology.
No, it's not.
For some systems, it depends on the approach of the operator. I've seen Telefonica, have more advanced topologies, but for simpler topologies, it's more like you leave the topology more, let's say, static or semi-static, and then it's a matter of path selection.
Well, yeah. If you consider virtualized topologies in the game, where you might have links going up and down, sometimes dynamically, you kind of need to have a real-time path computation sometimes. Well, in any case, I think this is a pain point in TFS that we need to consider revising.
Also for the end-to-end orchestrator, we need it, but I will not do a very big component.
No, it doesn't have to be big. I mean, even with a single algorithm, if it's consistent and it always does the work.
And the best step, I mean, just the shortest path. We don't need a very strong algorithm, or we need to work in most of the cases.
So basically, I also have a last slide, I think now, trying to get the discussion a bit more broad, outside of P4 specifically. I think things are also discussed in the previous talk, though, for that specific reason. We need to be careful on how we interface TFS with NSC. I think it's a very good opportunity now with this new group to also improve our APIs, our way of working within TFS. And especially for the case that I mentioned previously, when IETF Slice is able to see a heterogeneous data plane with a lot of technologies, it might be before optical or IP routers, I don't know, open config routers, whatever. This thing needs some abstractions so as to be able to translate an abstract IETF slice into smaller sub-slices which apply to different technologies. So we need to also work on this kind of abstractions in TFS because this is going to facilitate the mapping between TFS and the new group. I think that's all on my side as well. We'll see more tomorrow in the short demo that we prepared. But yeah, we are definitely willing to work in this direction from our side as well, not only for P4 but more broadly, because even in cases that we want to do external collaborations with other projects or partners, promoting a standardized interface is always better for them.
Yes.
We have seen cases where external partners say, "Oh, if you have a Teraflow specific API, we cannot do a proper integration. So we need to have, ITF, for example, or some 3GPP, whatever." So for us, it's quite crucial to get this done in a good way.
It's important that we work through Teraflow being IETF compatible in all MVIs of all services.
Yeah. And of course, for the P4 specific discussions, we can have specific talks about this because we have future plans as well for P4.
I have just one slide with some use cases we thought about that, well, maybe are more specific about P4, but I could share just one moment.
Go ahead.